Hello everyone, welcome back to JP Science. Today we're going to be talking a little bit about adding and subtracting vectors in one dimension. Alright, so when adding and subtracting vectors in one dimension, it's pretty straightforward because we're only working in either the x or the y direction and not both at the same time. So here I've defined our axes, x and y, and then I've defined upwards as positive and to the right as positive. Let's start with an example right away. Here I have written out the vector a plus the vector b, and the vectors are drawn up there, a, b, and c. So vector a and b both point to the right, and therefore they are both positive. And so this would be the same thing as doing that. So you can see vector a here, adding it to vector b. I've drawn it out according to the tip-to-tail method that I talked about in my last video. But here, mathematically, it would just be a positive 5 plus positive 3. And so the resultant vector, which is the vector sum of our two vectors here, a and b, would have a magnitude of 8 units. And the direction would still be in the positive direction because both of them are pointing to the right anyways. Okay. Here we have a minus b. Okay. As I said in my last video, minus b would basically mean that we're turning the vector b around, okay, and going in the opposite direction. And so our resultant vector would then be this vector here, from here to here. And so what that would look like mathematically is you would have positive 5 minus a positive vector that is flipped due to the minus sign, and now you have a resultant vector of positive 2 units. The positive tells us that this vector still goes to the right, as you can see here. Okay. Now I have a plus c. The reason I gave this example is because this is addition, but vector c is going in the negative direction. And so here, the vector c, even though we're adding, is already going in the negative direction. And so when we add them together, our resultant vector is that vector right there. Okay, and so this would be 5 plus negative 4. And this would give us a positive vector of 1 unit going to the right. Okay. Finally, we have a minus c. Remember, when we subtract, we flip that second vector here. And so in this case, c is going to the left. And so we flip that, and now it's going to be going to the right. And so we would basically be adding vector a, and from there to vector c, like that. Okay, and then our resultant vector would be this whole thing here. All right, so again, that would be positive 5 minus a negative vector, so minus 4. And of course, negative and negative, that makes it positive. So we're adding 5 and 4, and we're going to get a resultant vector 9 units. Again, the positive sign means it's going to the right. So this one, we have vector c, which is negative 4, meaning it's going to the left, minus vector b. Vector b is originally going to the right, but because we're subtracting vector b, it's also going to be going to the left now. That. And then when we add those together, we get a resultant vector that looks like this. So that would be negative 4 minus positive 3, and we get a resultant vector that's going to the left. And as you can see here, it has a negative sign, which confirms the fact that this resultant vector is going to the left, and it indicates that. That's why you don't have to write 7 units to the left, because you have a negative sign. If you wanted to write it another way, you could say 7 units to the left. Okay, to finish out the lesson, let's do some examples going in the y direction. So here you have vector d and e, which go downwards and upward, but still both are going in one direction, the y direction. So it's one-dimensional. And for vector d plus vector e, let's do this mathematically first. We know that this is going to be a negative vector because it's going downward, added to a positive vector going upwards. Okay, and we get a resultant vector, negative 2 units. Meaning that this vector has a magnitude of 2 units, and the negative sign indicates that it's going downwards. So the resultant vector is 2 units downwards. Okay. If we wanted to graph this just to prove it to ourselves, again, we can use the tip-to-tail method. So here's the first vector, vector D, and then we draw the second vector here. And of course, we would draw the resultant vector, which goes from here to there. And as you can see, it is going downwards, and it does have a magnitude of 2 units. Okay. Finally, we have vector D minus vector E. Vector D is a negative vector. It goes downward, and we're subtracting a positive vector, which is going upward. But since we're subtracting, we flip vector E around, and it's kind of like we now have a vector going downwards. And so that's why we get a resultant vector of -8 units. And I guess if I move this over here a little bit, I can draw here vector D would be that, and then we could add the flipped version of vector E there, and you would get the resultant vector of 8 units of magnitude going in a downwards direction.